Want to see how computer vision can enforce safety? In this tutorial, we'll walk through how you can fine-tune YOLO to detect safety violation.
Hello everyone, welcome to this tutorial. In this tutorial, we are going to fine-tune YOLO model to detect personal protective equipment. So what is personal protective equipment? As you know, these equipments which is worn by workers are called personal protective equipment, as it helps them to protect themselves from any physical injuries and even distinguish between them from other individuals. So in this tutorial, I am going to explain and perform how you can fine-tune a YOLO model to detect these personal equipment on your own from the scratch. As you know, YOLO model is only detect 70 classes which belongs to COCO dataset. And COCO dataset doesn't have a personal protective equipment class. So let's see how you can do it. I will tell you in very easy step. First step is to create a data set. Our our first step is to create a data set. So where we can get the data set. To get data set, you can check out some website like Pixels or Kaggle where you can get these kind of data set. So or you can just like me download a video, and from that video you can extract if frames or images for your data set. So I'm going with the second method. So before that I am uh, cloning a Git repository to access some required function. So I have cloned this Git repository where there are some functions which help me to create a data set. You can also do it same. So to first I have to create data set. I am using this video as an example. So I just have to provide the address to the video and extract random frame. This will create a direct and also mention the amount of images I want. I have around 2 or 3 videos in that videos repository, and I want around 30 images in randomly order from each video. So I will use extract random frame. So let's run this. So our 30 frames has been extracted and saved to output folder. So our next step is to perform annotation on the data set. So what does annotation mean? Annotation means is to create bounding boxes around the desired object I want to detect in my image or video. So do this, I have to go to Labellerr platform. As you can see, this is the Labellerr platform where you can perform annotation. First, we start by creating a data set. So as you can see, I have to select images as I am using images and name the data set. Let's so in next step I have to, as you can see, these are the images I have to select. So now wait for some times to get data loaded. When your image dataset is loaded, it will look like this. You can check the images. So these are my images on which I have to perform annotation. It's taking, now it's loaded. As you can see, these are the images on which I have to perform annotation. So These are. Now in our next step, I have to create a project. So to create a project, I have to choose a data set. I am choosing this data set which I have created. Next, we start by adding the classes for our annotation. Our first is safety helmet, which is of bounding box category. Then our next is a vest, which is also of bounding box category. And then for next, we have to start the next step. We proceed. Our project has been created. When its status gets active, we will start our labeling process. We will start our labeling now. We will start labeling image by image. So first we have to annotate here the vest, or you can choose the helmet. So we have to do this, then this, 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 this. There are two people here. So next is our vest. We will start by this, then with this our image has been annotated. Then we have to do the same process for the next image, and to repeat that process till our all the images in our dataset has been annotated properly. So I will skip the process as I have already annotated a dataset of my own for this tutorial. Let's go to the, as you can see, this is my project I have already annotated. I just have to, as, as you can see, the whole project is already labeled. So I just have to download my annotation in COCO JSON format. So I have to just go to export and create an export. When creating export, this will be created. So I have just to download in COCO JSON format and press download button. After which your annotation, if data annotation of your dataset will be downloaded in JSON format. Then you just have to go. Your annotation dataset will be like that. As you can see, there are image ID and image other data of images. We just have to go to the, as you can see, annotation part. These are annotation, these are the image ID and the annotation of bonding boxes. You can see these are the bonding boxes. These are X, Y, and height and breadth of the bonding boxes. So in our next step, our this step is over, and in our next step we have to convert our annotation.json into YOLO format. So what is YOLO format? In YOLO format you have a image folder or a labels folder, and label folder, it has the class ID name, and then x coordinate of the x coordinate of the most left top box, and the y coordinate of top left box, and then height and breadth of the bonding boxes. In this way you have to store your data. You can simply do it by using my script YOLO find to utilize dot COCO YOLO converter dot bonding box converter, and import COCO to YOLO converter. I will do that. As you can see, so there is a problem. Uh, these are the, I let me, so these are not able to. Now let's see what's the issue here. Let me try this. So yeah, it's working. As you can see, our YOLO format has been created. These are the images and these are the labels. Let me show you the labels of that. These are the class 1 ID belongs to helmet, and class 1 belongs to vest, and class 0 belongs to safety helmet. And these are the bonding boxes. These are the X, Y, Y, and the height and breadth of the bonding boxes. So in this way you have to store all the annotation of the image with this. Hmm. Then in our next step we will start the main fine-tuning process of a YOLO model. In our next process of YOLO fine-tuning, we will start by installing Ultralytics. So our Ultralytics package is installed, and we have to import this Ultralytics lab module. Then from Ultralytics we have to import YOLO. Then now my present working directory is this YOLO fine-tune YOLO for PPE detection. I have to provide it with the dataset part. The dataset part is this YOLO format. So I am providing the YOLO format into this dataset part. Now let's train our YOLO 11 model. So we will start by our task, which is detection mode train dataset part, which is this, and then dataset.yml. So what is YML? This is YML which is created. It contains the parts to our image folder and the all other metadata like which classes is for which class name. So 0 stand for safety helmet, 1 stand for vest. So let's run this. As you can see, I am using YOLO 11x model. It's getting downloaded, installed, as you can see, and I will run it around 200 epochs on a batch of 30. So it will take some time. Hmm. So when the training process will be over, you will see a runs folder is created. In this run folder, there will be a detect folder in which there will train folder, and in that you have your model. In weights there are two model, best.pt and last.pt. Best has the by name the best configuration, and last is the on the last epochs it is trained on. So let's see the inference result of our custom model on a video. So I am providing it with the part to our best model and also with the sample video part, and saving that video, and I'm showing you without the labels. So let's run this. As you can see, our model is running and our result has been saved in predict. So as you can, the predict folder has been created. As you can see, there is our video. Let's see its inference. Similarly, you can also influence other video just by changing the part to a video like this. Let's run this and check the inference. With this, our YOLO fine-tuning for PPE detection is completed. Now you can uh, create a fine-tuned model of YOLO to detect PPE on your own.
For more computer vision or machine learning related tasks, you can check our GitHub, where you will find everything in one place.